Good morning, children. Till now, we have studied about the electric field around the charge, which can be expressed in the two ways. Once, it is explained by electric field vector E. And the second part, how we can identify the electric field around the charge, is nothing but the electrostatic or the electric potential V. Now, electric field E is a vector quantity, but electric potential is a scalar quantity. And both the properties or both the quantities are characteristic properties of any point in the field, and they are interrelated. Now we are going to describe how the electrostatic potential difference can be created and what is the actual definition of electrostatic potential. To understand this, we have drawn here the diagram. Now let us consider that source charge plus Q, which is having a large magnitude, is placed at point O. And the another charge, which we call it as a very small positive test charge, is located at a distance at a point A. Okay. Now suppose this force positive charge and this also is having positive Q naught. Both the charges exert the repulsive force because both are having the same polarity. Obviously, the test charge Q naught is very small. Therefore, if I want to move this positive test charge towards the charge plus Q from position A to B, then I have to move this charge against the repulsive force of the plus Q charge at O. This means that this positive Q naught charge has to move from A to B against the electric repulsive force due to this plus Q charge. Therefore, when the test charge Q naught is moved from A to B, the work has to be done that is called as a WAB in moving against the repulsive force exerted by this particular positive charge Q plus Q. So when we calculate the potential difference between these 2 points, then we can write down in the method V is equal to VB minus VA, that is given by WAB divided by Q naught. Now obviously here the point A is considered to be having the less potential and point B is considered to be having the high potential, because to move the charge plus Q naught from A to B, more work has to be done as we move towards the plus Q charge, because the work has to be done against the repulsive force. Therefore, the amount of work done in moving the charge from A to B, which charge? Q naught charge, is called as the potential difference between these 2 points A and B. So I can say that VB is at the high potential and VA is considered to be at low potential. Therefore, potential difference, if I want to write down potential difference between the 2 points in an electric field, is the amount of work done in moving a unit positive charge from one point to the other point against electrostatic force. In this above definition, we have assumed that the test charge is very small, so that it does not disturb the distribution of the source charge. And secondly, we must apply so much external force on the test charge that it just balances the repulsive force on it and hence does not produce any acceleration in it. Therefore, we can write down about the SI unit of potential difference in terms of volt. and it is written by 1 volt is equal to 1 joule, which is the unit of work done, divided by 1 coulomb, which is the unit of the charge. So work done divided by charge, test charge, is called as the 1 volt. Now 1 volt again can be written as joule is the work done, and we know that W is equal to Fs. So therefore 1 force, F unit is N, S unit is meter, divided by 1 coulomb. So it is written as 1 Newton meter coulomb raised to minus 1. Also it is written in terms of directive work done upon coulomb, that is joule upon coulomb, is equal to 1 joule per coulomb. So 1 volt is considered to be having the SI unit 1 joule per coulomb. Therefore, I can express the definition of 1 volt in terms of, it is potential difference between 2 points in electric field is said to be 1 volt if 1 joule of work is done in moving positive charge of 1 coulomb from one point to other point. Now this is about the definition of the potential difference. Now if I want to find out the electric potential, then we will define the electric potential in the different way. Electric potential. Now let us consider that if the test charge Q0 is very far away from this positive charge Q, if this positive Q0 charge is at a very large distance or at infinity, then we consider that electric potential at that point, infinity point, is considered to be 0, and therefore we can say that VA is equal to 0, and we can have V is equal to VB is equal to W upon Q0, because now we have to bring the charge from infinity to point B. Therefore W is the amount of work done in moving the test charge Q0 from infinity to the point B, and VB now refers to the potential at point B. Therefore electric potential, now I can write down in terms of the definition, V is equal to work done in moving a positive charge from infinity, if this charge is at infinity, then we have to move this charge from infinity to that point, then amount of work done in bringing the charge from infinity to point B is called as the electrostatic potential. And SI unit of electric potential is also volt.